Okay, then, hello everyone, my name is Michael. I'm currently working for SAS as a data science consultant. And before I came to SAS, maybe just some background knowledge from my side. I studied at IBM doing Wirtschaftsinformatik, business informatics. Then I worked for KPMG, for Bearing Point, another consultancy firm. And now since December last year, I changed to SAS. And today I want to talk about how to operate models, mainly in this case, how to operate open source models. So we are talking about Python models in this case. And I do it on a specific use case. It's called entity extraction. So we have a text and we want to grab the entities from it. For example, we want to extract times, we want to extract organizations, we want to extract persons, and so on. And we are not only going into how to build such models, because this is only a very small part from my talk today. But I will present a way how you can use these models in a way, for example, in the business world, so that normal people, not data scientists, are able to actually use your models to generate knowledge. Because what I always see is that I'm coming to companies and they ask us, especially SAS, hey, we have these nice models, but how can you operate them? So currently, in most cases, they are stuck in the data science community in the enterprises, and nobody cares about, okay, how can you actually make it work for the normal people in the company? And that's what I want to talk about today. As said, the use case overview, so yeah, it's how to operate models. In this case, it's entity recognition, so I will talk a little bit about two kinds of models I created in Python using Keras to do entity extraction. After that, I talk about how to create a web service with it. I'm using Flask, a very well-known Python microframework. And afterwards, I give a very short live demonstration how this could look like. Please be aware, I'm not a very good web designer, so it's not very beautiful. I'm a data scientist, but I hope you get the idea behind it.
This is, I think, very important. That's like for me. If the slides are good, then the guy is not really a good data scientist. He's more into sales, you know.
To be honest, most of the slides I took from some slide designs on the internet, so I did not really create.
Now it's becoming difficult to hire a data scientist.
I wouldn't be able to do such beautiful icons and so on. I just grabbed everything on the internet. However, let's go on. So the use case overview is how to operate models. And how it looks like in reality is like this. So people spend a lot of time creating very beautiful models. They have a very good performance. We say, hey, these models are very nice. I guess my colleagues will benefit from it. But actually what happens is, if you look at how often your models are used, it's not that often. And the reason is why. And when I come to companies, even the bigger ones, sometimes it looks like this. Yeah, they have the Jupyter notebooks, and of course, if you're a data scientist, you know what to do. You know how to operate a model using a Jupyter notebook. But think about your normal colleagues who are maybe not in the IT department. They don't get anything there. Another thing is maybe they already created a nice application from it, and you have these very beautiful command line tools where you can push requests to your models. But of course, if you show a black screen with only some very curious statements in there, your normal business departments won't be able to do that. So the question is, why don't we make it simpler? And this is, I would say, a very nice example from spaCy. It's a very common framework in Python to do NLP. And they have a site where they have a lot of different demonstrations. And this particular example here is the entity recognizer from spaCy. And I nearly built the same, but not using spaCy in the backend, but using Keras, so neural networks in the background. But I use the printing functions from displays in this case to have this nice visualizations. And this is actually what we want to do. We want to create nice models, but we also want to have a nice application around it so that other people who are not a data scientist, for example, are able to use these models. So let's talk a little bit about entity recognition. So how is it done? And I have a very simple example as the first step is what are we trying to do? We have a text, and I only highlighted the extracted entities here. And even if you only see these entities and maybe just following a little bit the news, you should be able to recognize what this text is about. So for example, in this case, you can see it's about Volkswagen. We have Dieselgate. We have Oliver Schmidt, and maybe if you remember, Oliver Schmidt was one of the managers from from Volkswagen. This is a whole text behind it. We are not going to read it right now, but I can tell you it's about him who got arrested in the US. And this should only show, okay, we have a text with a lot of information, but not all of this information is important for us. So we created a model to extract only the entities from it. And taking only these entities into account, we could normally, in most cases, already guess what the text is about. And this leads us to the question is, this is a link to the demo I use for this. This leads us to the question, okay, what are we going to do with entity recognition in the real world? And there are a lot of different use cases. I only took 3 of them as an example here. The first one is news classification. Imagine you're a very big news provider. You have a lot of articles, and you want to classify them in some way. This is also done by Google, for example. If you go to Google and click on news, and they already categorized all the different articles. So there's no human behind it who is saying, okay, this is an article about politics or soccer or whatever. This is normally always done by algorithms. Another thing is efficient search algorithms. Imagine you have a lot of different text and you want to do a search query against it. Normally, you don't want to go through all of the text, but only through the important parts of the text. And this is what you can do with entity recognition. So you save for every document, for example, only the most important entities, and when you do a search query, it does not log into the whole text, but only into the entities. This is much more efficient than doing a search through the whole document collection. And the last part, and this is also something I tried to show today, but I have to say I'm not a very good guy in biology, so please beware. I don't have any clue if my models are currently doing anything correct, but at least I tried to do it. This is entity extraction in the terms of biology. For example, you have a lot of different research papers where people mention DNA or proteins and so on, and you want to know if they are somehow connected to each other, if they have an influence on each other, and you want to extract the entities from all these texts and then, for example, do a correlation matrix and see, okay, which DNAs, for example, are always mentioned together so that you know, okay, they might be somehow related to each other. I said these are only a few of the examples you can achieve with entity recognition. How do we create a model for it? As said, I used Keras with TensorFlow as a background framework in this case. Of course, we always have to do some data preparation. We have to define our model. In this case, it's a deep neural network. We are doing a model training, and I can say I used AWS machines with a GPU acceleration in the background, and I could achieve to train a model in like 1 hour. If you try it on a just CPU, for example, be aware that it takes much, much longer. Afterwards, model assessment, of course, so we want to know if our models are performing good. And this is where I want to say, don't stop here. As said, what I always see in the companies is that they try to create the best models, but nobody thinks about how to put it in an application, for example. And this is what the next chapter will be about, but maybe let's look what I did for today. I created 2 different models. I don't want to go into the details right now. If you want to talk about neural network architecture, I guess there are better experts than me. But if you want to talk about today, just wait till I have a beer in my hand, and of course we can try to talk about it. What this should show is that we have 2 different models. One is using just word embeddings. I hope everyone knows what word embeddings are. The other one is also using character embeddings. You can see they have nearly similar trainable parameters. It's still a quite small network. Yeah, the one on the left, the simpler one, took like 40 minutes. The other one, like 1 hour. You can see it's quite funny that they nearly performed equally in both cases. But the model size, this is something I want to emphasize in this case. You can see just a very small addition on some more information in the model can lead to a slightly different model. If you take even bigger models, or if you take, for example, pre-trained embeddings from, for example, Google, you end up with like 2, 3, 4, or even more gigabytes, which you have to load to actually do a computation with your models. And this will become very important later when we talk about an application. So keep in mind, model size is always important if you want to operate some models.
Yeah, sorry to interrupt. Maybe you can tell what word embedding is exactly?
Oh, yes, of course. Word embeddings is basically a way to put a word into a vector so that you have also its surroundings as information. So for example, what you can do if you have very well-trained models on a quite large corpora, that you can do queries against these word vectors, and for example, also do simple computations. A simple example would be if you have, for example, woman and queen. This would be, for example, very near to a king and a man, for example, because they are always used in the same context in text, so that you know, okay, they have nearly a similar meaning. As said, so word vectors are basically just vectors of words which also incorporate some surrounding information, not only the word itself. That's why they are quite useful in, for example, text analytics. But I think on the next slide. Oh, so for today, my example is LSTM with character embeddings. LSTM is a long short-term memory. It's, I would say, the de facto standard in NLP tasks, especially if you talk about entity recognition. I took data from Kaggle actually, so of course we need some training data to create our neural networks. So if everyone wants to follow what I do, everything's available for free on the internet. In this case, it's Kaggle. And what do we have from Kaggle? We have a simple data set, which you can see on, in your case, on the right side. It's yeah, more or less just a table containing about 48,000 different sentences, and these sentences are tagged. For example, you can see here that we have a geopolitical entity, we have a time entity, and geographical entities. This data is used to train the model later on, but of course, as I said here, neural networks don't know words. So as a first step, which you have to do in every case when you want to train a neural network, is to transform these models into some kind of numerical representation. I did a very simple approach here. So for every, or you can see it here on the left side, for every word I have a unique number behind it. And of course, I added to the additional words. Yeah, one is for unknown words. So think about the scoring later on. This model is trained on a corpora, but of course this corpora does not contain any word which we want to score later on. So that's why I added an unknown word indicator for later scoring. As well as we have a padding, so of course our sentences are not always the same length, but for training the model we have to tell the model, okay, what it can expect. This is why we are using this padding information here. This is basically what is done. So on the top you can see the words are encoded just with simple numbers. We also have characters for each word. In this case, they are limited to just 10 characters each word. So everything which is longer than 10 characters is cut down. And yeah, the last one, of course, the entities are also encoded. So the 8 and the 7 and yeah, 8, 7, and 10 stand for different entities in this case. The 7, as you can see here, is just the outer-bound entity, which is not very useful for us, but the time and the geo information is also encoded here. So this is what we put into our Keras model. And this is actually how our Keras model looks like. It's a quite simple one. And as said, I don't want to go into every detail here, but maybe just keep in mind we are currently putting in two different kinds of information. One are the characters of each word, and one of the words in each sentence. And these word embeddings, which I was talking about, actually, does it work? For example, this calculated in this layer and also in this layer. So we are, in this case, training our word embeddings ourselves, meaning that my corpora is quite small and my word embeddings are not very good. Normally, you would want to take a much larger corpora, and especially a corpora which is based on your domain you want to predict later on. In this case, it's, as said, just a very small sample corpora from Keras, so the results are not that good. However, it achieves quite a good performance in some of the entities. You can see here, for example, event and artwork are quite bad. It's simple to explain because the Kaggle dataset does not contain much information about, for example, artwork. And if you don't have enough data to train on, later on it won't be able to recognize these entities on a new dataset. However, it's not that bad. Normally in this domain you get performance scores around 90 to 95%, so it's in most cases even better than humans do, so it's quite well researched area. However, for our use case today as a demo, I think this is quite fine. We have created our model. As we saw, it performs quite good in some cases. And now we are thinking about, okay, how can my, for example, colleagues from, I don't know, the finance department can use it. But first of all, start with why do we want to create a web service for it? And there are different kinds of, I would say, positive effects to do so. So the first one is accessibility. As said, not everyone is a data scientist, not everyone is able to program. And in this case, the people are just not using your model. So if you provide them with a nice application, you enable them to use analytics, even if they are not an expert in developing it. Another thing is integration, and this is what currently I'm doing for SAS as well. I have some clients who want to integrate these open source models into our software, and today I will show a very short demonstration how this could look like. So actually this, what I'm showing here, was also a little bit developed because I had to do it for one of our clients. The other thing is standardization, so thinking about having a lot of people using your models, and you want to make sure that everyone is using the same models, everyone is using the same APIs, and everyone is getting the same results. It does not make sense to have everyone use a different model, because if you cannot compare the outcomes, it doesn't make sense to use these models at all. Computation power is also very important. As said, I have very small models here, but if you think about bigger models, no one wants to really do the scoring on his, for example, personal laptop. So that's why it comes handy if you have, for example, a big data center, or if you are working in the cloud, to just give people access to this computation power by providing this model on a single point of contact. Model complexity is more or less also the same, but very important, I would say, is also the model management. This is also something I see in a lot of companies. Nobody thinking about, okay, we have created now a very nice model, but is this model still good in 1 week, or is it still good in 1 month? And I would really emphasize to have a single point where you have all your models stored, where you have all your updated models stored, and where you do your performance measurement about these models. And that's why you always want to have, as said, a single point of truth for your models. So we have different reasons why we want to do it. And here is my way how I achieve, or how I try to achieve all of this. And the first one was a very naive approach. To be honest, I was also not a big expert in this case, but I learned a lot in the last few weeks and months. So the first approach was to use the common gateway interface. So we have an HTTP server. In this case, it was Apache. And I wanted to run Python models. So my HTTP server was, or should have been able to execute Python scripts. You can achieve this with a CGI interface. It's a very old interface, but it does what I wanted to do. However, it's not the best way to do so. Also, what I did in this case was I created a Python script which does scoring and handing the results in one file, and I can tell you it was horrible to manage this file. So in the next step, what I did was I split it in two parts. So I have one scoring function, which was pure Python, and I had one result handler, which was able to handle these results and, for example, display it on a web page and display it in SAS and also store it in SAS. This became better. However, the biggest problem here is that this common gateway interface creates one process per request. So thinking about like 100 people are using your service, you have 100 processes, and each process is loaded just by request. And here comes now the important thing about the model size. If you have small model sizes like I had with, let's say, in total like 10 megabytes, it's no problem for a machine. But of course, if you have a big model with, for example, 10 gigabytes and you are loading this model every time, it's not usable. And now comes the important part. This one is quite okay for testing and see okay if it is even possible to do so, but it would be better to do something like this. And I used Flask. It's a micro web framework for Python and an add-on for Apache called mod_vsgi. And this allows you to actually have this Apache server execute Python scripts. So for example, our trained models, but not only execute it, but have it in memory before you even have a request. This means this model does not have to be loaded every time, but is already loaded when you start the server. And of course, this is quite a lot faster than loading the model at each request. I also made a more complex but better manageable web application here. So the scoring function is the same as I had before. The result handler is the same as before, but I added a connection handler. So for example, this could also be used to have multiple users access your web server at once. And this is all done by the connection handler. What you will see in the live demo is especially these two parts here. So one is just a very simple, I said I'm not a web developer, so be patient, it's not very beautiful. A very simple web page where we can actually post a request against a web service and get back the results. And the other one is a very short presentation, how this can be integrated into SAS. And yeah, this is what I would like to show. Okay, perfect. Until now, I did not show so many codes, and if it's okay for you, I also won't do it right now. I already got asked whether I can share this code, and I can say, of course, I can. However, I did not yet come to upload it right now. But if you're interested in, just let me know, and I can, of course, share it. Maybe let's start with looking at one of our models, because I think maybe it's interesting for some of you to see how this looks like. So this is the example I showed in the presentation. This is our long short-term memory with character embeddings. We have this data available here. We are creating the unique IDs for it so that we can actually put it into our model. So creating the numerical representations from it, doing some padding so that we have all of the sentences in equal length so that they can actually be put into our model. And this is how you would define a very simple model in Keras. So Keras is like an high-level framework for TensorFlow, so please don't ask me any questions about TensorFlow. I'm definitely no expert in it, but however, Keras I can use a little bit at least. And yeah, as said, it's a very high-level framework. It's like building Lego bricks on each other, so it's quite easy, I think, also for newcomers in this area to use it. And yeah, this is what we have done here. So we are just stacking one layer on each other until we have our final model. We are compiling this model. Here you can choose between different loss functions, metrics, and so on. But if you want to know more about it, I would recommend to just read a book about it, because it's quite difficult to get all these in one talk. We have this training section here. You can see one epoch took like 500 seconds, so it was quite long even on the GPU. And then you can, of course, create also these nice curves so that you can see how your model actually performs. You can see here it's like nearly 97%. However, this is only calculated on the training data. So if we take new data, this drops below like this 80% I showed on the slides. So this is basically what you do for the training. And then comes the interesting part: what do we have to save from this model to be able to score it? Or saying it other way around, what files do we need to put into our web application to be able to score new documents? And this is basically all we did to create this model. So we have to get our sentences or our words and characters put into numerical representations. We have created dictionaries for it. So of course we will need these dictionaries to do it for new sentences. And of course we have to store our model itself. So all of the weights which were learned during the training process are stored in a file here. Keras is quite handy in this case, so it lets you store the model in a very simple way, like you can see here. Yeah, as said, this is how you would create a model for it. And then if you want to build an application for it, you have to do a little bit more coding, because we're creating an application now. The first example I show here is a very simple HTML page with some JavaScript in the background, which is capable of taking input from a simple text area and puts it into our model, creates the scoring results, and displays it on the page. And yeah, as said, we have a very simple HTML here. This is just more for the representation. And the interesting part is the JavaScript behind it. So what we have here is what we have here is JavaScript. So what it does is, so JSON is very handy if you are working in the web development environment, and puts it into our web service. And this JSON is then transformed into a simple pandas data frame in Python, scored, and we are receiving the results, in this case, only as an HTML representation made by spaCy, so that we have a visualization of our entities extracted. But of course, you can also think about more complex cases, and this is what I did for the SAS part. We are always writing back the results also in our server. So for example, that you can use it later on to do further analysis using your extracted entities. But for the first case, what I want to show is how this could look like in a simple page. So in this case, it's our entity extractor. You can see it can detect, I think, 7 or 8 different entities in this case. As said, event and artwork are not very good, so don't expect anything to see here right now. But however, the other ones can be extracted, and I hope I find the right center. So what you can do here, just take one of the samples I have here, insert the text, and here you can choose between different models. As said, I have Keras models, but also, and to be honest, they are quite better, the built-in spaCy models available here. And yeah, if we then click on Analyze, on the right side, we get the results. You can see here, the model is not perfect, but at least some of the entities are quite okay. So for example, Criminal Bureau of Investigation sounds good. That is an organization. Frankfurt is indicated as a location. Thursday morning is the time indicator. So this already works quite good. And what I really liked is because we now have put everything into an application, and this application is loaded in the background and not on request basis, we could also do something like this and do it in a live demonstration. So for example, you can see here that yeah, it actually works in real time. Okay, maybe the results are not the best ones right now. However, you can see the scoring takes place in real time in the background. This was only possible by creating this application and not loading it every time again when we do a request against it. Another thing is, which I built for just a very short demonstration, is this one, this biology extractor. And you can see here this model is capable of extracting 5 different entities in the biology field. More or less the same demo as I showed in the other demonstration. But here it's important to know we only have 2 different models. Why is that? Yeah, spaCy was not trained to extract entities in the biology field, so of course I cannot use it to do this kind of stuff. And yeah, you can see here, as said, I'm not an expert in biology, but some of them sound okay for me, so not the worst results. And yeah, this is how it could look like in a simple web application, just using some HTML and JavaScript. And now I'm coming to the last part. This is our SAS environment, SAS. And we have one tool called Visual Analytics, and it's mainly based for doing graphical exploration of your data. You can also use it to do some analytics on it, but in this case, it's only limited normally to SAS procedures or SAS analytics. However, starting with the last version, we have introduced a very cool new feature. This is called a data-driven object, which you can see here on the right. And everything it does is it creates an iframe so that you are capable of displaying your HTML file. But also, it is capable of getting data and sending this data to some other place. And in this case, when we go to options, you can see here a URL. And this is actually the URL where I have stored my HTML file. And this HTML file is includes a JavaScript, which is actually doing my request against the web application. What you see here now is exactly the same web application I used in the simple browser-based demos. So this is not a new model, this is not a new service, it's the same application, but just used in a different environment, in this case in SAS. And as we now have access to a little bit more data, we can actually, for example, here on the left side, we have different news articles from CNN and I think, yeah, Business Insider. And what we can do here is also select different models. Yeah. For example, we now use some spaCy models, and then just select some models here, and perfect, it works. All the data I selected on the one side is now transferred to the web application I have integrated. It gives me this nice representation of the entities. So this is all the text annotated. And what I did in the background as well, we have this data now stored into our server. So for example, if I go to my data, I can add a new data source. And if you know where it is stored, we have this TA, it stands for text analytics, and you can see here that, for example, We have our organizations, and I hope it has some data because it found some organizations in our text. As you can see, yeah, using Keras models or other open source models is quite nice. I really like to work with it. However, I would really emphasize to think about operating these models so that other people can use it. And this is what I currently see in a lot of companies, what the data scientists are not thinking about. And as you see, it's not that difficult to do so, even though I did not show the exact details how to set up a Flask web service, but I can tell you that there are very simple tutorials to do so. And I guess if you are interested in, you will get it done in like a half day or 1 day. Okay, thank you very much. That was it.